Imagine a place so distant, so frozen, and so inhospitable that even with all our modern technology, no one, absolutely no one, has ever set foot there. Now imagine that this place is right here in our own solar system. We're talking about Pluto. And as fascinating as it may seem, here's a truth few people say out loud. Humans will probably never make it there. Not anytime soon. Maybe never. Reaching Pluto is one of the most difficult tasks in space exploration. This tiny dwarf planet is located over 6 billion kilometers from Earth. To grasp the vastness of that distance, consider this. The only spacecraft to ever reach Pluto was New Horizons on July 14, 2015. And even then, it didn't stop. It just flew by, took a quick look, and continued on its journey toward the edge of the solar system. But why invest so much time, money, and technology for just a brief flyby? For decades, Pluto was known as the 9th planet in the solar system, and the most distant one. Located on the frozen edge of the Sun's domain, it was commonly believed that reaching such a remote world would take centuries, but a rare opportunity came much earlier than expected. In 1964, engineer Gary Flandreau from NASA's Jet Propulsion Laboratory, JPL, realized that between 1976 and 1978, there would be a rare alignment of the giant planets. This alignment, which only happens once every 176 years, would allow a single probe to visit multiple planets using successive gravity assists, using the planet's own gravity to speed up and save fuel. NASA then proposed an ambitious project called the Grand Tour. The idea was to launch 2 twin probes called TOPS that would follow this interstellar route. One would visit Jupiter, Saturn, and Pluto, while the other would go to Jupiter, Uranus, and Neptune. The plan was for the first probe to reach Pluto around 1985 or 1986. However, the Grand Tour's cost was deemed too high for the time, and the project was ultimately canceled. In its place came a more budget-friendly alternative, the famous Voyager probes. They would follow similar paths to those in the Grand Tour, but with a more limited scope. Voyager 1, in fact, had the option of heading to Pluto after visiting Saturn. But NASA chose a different plan, redirecting the probe to fly by Titan, Saturn's largest moon. This decision, though scientifically and strategically valid, meant another no for Pluto. The reason for these cancellations was always the same: distance. Pluto is unbelievably far away, and back then, technology was still crawling when it came to dealing with such challenges. The Voyager probes, for example, didn't even use solar panels since sunlight is too weak in that remote region. Instead, they were equipped with nuclear batteries that generate energy from the heat of radioactive materials. But there was a real concern. Would this energy last long enough to reach Pluto? In the end, it was decided that the risk was too high. The priority became using the available power to explore Titan. Interestingly, even after the flyby, Voyager's batteries kept working, something no one expected. That was luck. But it didn't change the fact that visiting Pluto was a complex, expensive, and, above all, risky mission by the standards of the time. This view persisted for many years. Pluto was labeled small, lonely, and distant, not worth, according to some scientists, such high investments. After all, why spend billions to study a dwarf planet when the gas giants and their dozens of moons offered so much more material for research? But time passed, and curiosity about Pluto didn't fade. On the contrary, it grew. In the 1990s, astronomers began finding other small celestial bodies beyond Neptune's orbit, in a region called the Kuiper Belt, a vast area filled with icy objects like asteroids and primordial comets. Pluto, then, was no longer an isolated case and became the key to understanding an unexplored region of the solar system. Suddenly, it was more important than ever. It was in this context that the New Horizons mission was born. The proposal was clear: build a small, lightweight, and extremely fast probe. Its main objective would be to reach Pluto in record time and collect as much data as possible during a brief flyby. NASA knew it would be impossible to slow down the spacecraft upon arrival, so the entire mission had to be done on the move, like taking a photo from a car speeding down the highway. The launch took place on January 19, 2006, and with that, New Horizons made history. It became the fastest spacecraft ever launched from Earth. In just 9 hours, it had already passed the Moon's orbit, something that took the Apollo missions 3 full days. It was moving so fast that, despite all technological limitations, the probe could reach Pluto in just 9 years. Along the way, it flew by Jupiter in 2007, using the giant planet's gravity as a kind of cosmic slingshot. This extra boost increased its speed by 14,000 kilometers per hour. And it wasn't just a technical maneuver. The encounter with Jupiter allowed the spacecraft to test its instruments and collect valuable data about the Jovian system. Over the following years, New Horizons crossed the vast emptiness of the solar system with one clear destination: Pluto. Each day, the distance to the dwarf planet decreased, but the precision required increased. Even a tiny deviation could cause the probe to miss its target by hundreds of thousands of kilometers. Finally, in July 2015, the long-awaited moment arrived. New Horizons made its historic flyby at just 12,500 kilometers from Pluto's surface, revealing a world completely different from what scientists had imagined. Expectations were for a dull, icy planet with little to no activity. But what appeared before the cameras was a world with ice mountains as tall as the Alps, deep valleys, smooth plains that suggested recent geological activity, and even a massive heart-shaped formation that became the mission's iconic symbol. Pluto, once seen as a vague dot in the sky, gained definition, color, and personality. It was as if it had finally stepped out of cosmic anonymity to become a celebrity on the solar system stage. And it was all thanks to the boldness of New Horizons, which showed us that even in the farthest corners, the universe still holds astonishing surprises. But that feat didn't make the challenges disappear. The mission had to deal with a communication delay of over 4 hours to send or receive any signal, due to the incredible distance. That meant any command sent from Earth arrived late, making last-minute corrections impossible. It was like driving a car blindfolded, relying only on pre-recorded instructions. Even after the historic flyby, the challenge of studying Pluto remains enormous. New Horizons couldn't enter orbit or slow down for a longer analysis. It simply passed by, capturing as much data as possible in a very short time window. After that, it continued on its path to study other objects in the Kuiper Belt. And even today, despite being so far away, the probe continues to send information back to Earth, slowly, but with priceless scientific value. This limitation raises a question that many still ask today. Why not send a mission that could actually orbit Pluto? The answer is complex, but it essentially comes down to one word: speed. To get there in less than a human lifetime, a spacecraft needs to be incredibly fast. But at the same time, to enter orbit, it would have to drastically reduce that speed when approaching the planet. And slowing down something traveling over 50,000 kilometers per hour, billions of kilometers from home, requires an unbelievable amount of fuel, something unfeasible with today's technology. Some scientists have proposed possible solutions, such as using electric propulsion powered by nuclear energy, or even braking systems with reversed solar sails. But all of these ideas are still in the conceptual phase or undergoing limited testing. That means, for now, any mission to Pluto will continue to be a touch-and-go type. And there's more. The time it takes for a mission to get there is a major obstacle to the viability of these projects. A spacecraft like New Horizons, which took 9 years, still represents one of the shortest possible journeys. But slower missions, like those with humans on board, could take 15 to 20 years just to arrive. And in a world where technological advances happen in cycles of 5 years or less, the risk of launching something that becomes obsolete before even completing its mission is very high. On top of that, the cost of maintaining a dedicated team for a mission lasting 2 decades is enormous. That's why manned missions to Pluto are, for now, completely unfeasible. Just keeping astronauts alive during a round-trip journey would require decades of planning, millions of liters of supplies, and life support technologies that are still far from becoming reality. Not to mention the exposure to radiation, the effects of microgravity over long periods, and the extreme psychological isolation. Even so, Pluto remains a fascinating target. It teaches us that the solar system is far from fully understood. It shows that even small bodies in the distant reaches of space can have atmospheres, active geology, and even the, however remote, possibility of harboring life in underground oceans. And it reminds us that behind scientific classifications like dwarf planet, there is a real world with unique features and stories to tell. In our hearts, Pluto will always be Planet 9. Today, Pluto is also a symbol of human persistence. It represents what is far away, difficult, and seemingly out of reach, but that, with ingenuity, patience, and courage, can be achieved. The New Horizons mission proved that even a brief encounter can completely transform our understanding of a planet. And who knows, maybe in the future, new generations will witness the arrival of a spacecraft that doesn't just pass by Pluto, but stays there, exploring it in detail, perhaps even with humans on board. Until then, all we can do is keep looking to the sky, imagining what else we might find on the frozen frontier of our solar system, and dream of the day when the impossible becomes routine in the exploration of the cosmos.